Hello everybody, welcome to my YouTube channel. My name is Hafez and today I'm going to be talking about linked lists. We know that in arrays we have such thing as an index, which allows us to directly access a specific data. But instead, in linked lists, we have pointers. So we can't directly jump into a data that we are looking for. We have pointers and a data in linked lists, and the building block of a linked list is a node, and this is how we draw them. Basically, we have a data here. We also call it a key. And then we have next pointer. If our node had only a next pointer and a data, it would be a singly linked list. A singly linked list. But if we had a previous pointer too, then in that case it would be a doubly linked list. And as you guys can guess, we're going to be using the doubly linked list more than singly linked list because it's more complicated. And it is also worth noting that a linked list is a concrete data structure, a real implementation, not an interface. It's commonly used to implement abstract data types such as stacks, queues, and lists. And in linked lists, we have three important operations that we need to know about. We have search, we have insert, and then we have delete. These three operations are very important, and I've already prepared the Python codes for each. And as you guys can guess, our linked list starts with no object, so the head is empty, and so is the prev and next. Moving up to the search operation. As you guys can see, first of all, it has a big O of n, which determines the complexity of our operation, and it's because of this loop here, this while loop here, that basically if we go well, it's the worst case scenario. If we go through all the nodes, and in that way we'll have a big O of n. And so what it does is that the traversal starts at the head, and the while loop advances one node at a time via the next pointer, and comparing data at each step. And as I said, in the worst case scenario, the loop traverses every node, making this whole operation a big O of n. Moving up to the insert operation here, and it's also again worth noting that our insert operation will always insert a new node at the beginning of a list. And as you guys can see, there is no loop here, so it won't be a big O of n. Instead, we have a big O of 1 because these are all just values. There is no loop here. The new node's next pointer is set to the current and our current head. The previous pointer is updated if the list is doubly linked and head is reassigned. Each statement executes exactly once, regardless of its size, which is what gives this operation constant time. A big of 1, basically. And moving up to our last operation, we have our delete operation. And as we had with search, we have a while loop here, which basically gives us a big O of n, just like the search. And how it works in simple words, in order to delete a specific node, we're going to have to find it first. So we need to use the search operation. And then when we did that and we found our node, our desired node, we can now delete it. And this search operation gives this operation a big O of n. And the delete operation itself, the pointer relinking, is constant time, basically. If a direct reference to the node were already available, eliminating the need to search, that operation alone would run in big O of n. Thank you so much for watching and listening to me. That must cover everything about linked lists, and see you guys next time.